thinking about y equals a b to the x every time, where this is your starting value and b is always going to be your ratio. So what are you multiplying by each time? Is it doubling? Is it a percent interest rate? Is it decreasing? You wants to invest $1,000. Find the value of the account following two options and make a recommendation. So which one is better? 3% interest over 5 years or 4.5% interest over 3 years. So I'll set up the first one for you and then you set up the second one. So my A value is $1,000. And if she's getting 3%, this is growth. So it's 1.03. So you get 3% growth and you get your 100% of the initial investment back. And then I'm going to raise it to the fifth power to see after 5 years. Who needs a calculator out there, Dad? You might. You need one? Got one, you got one, you got one. Yep. Anybody? You have one, right? Okay, everybody has their own. So what do we get when we type it in? 1,000 times 1.03 raised to the fifth. I get 1159, and I'm going to round to the nearest penny because it's money. So 27 cents. There I did. I typed it in. Anyone have questions on that one? Can you try to set up part B yourself? This seems like a reasonable question, right, for the unit test on Friday, compared to account sizes. Or I might ask you, how long does it take to double your money? So you would have to guess and check your years and try to come out to $2,000 at the end. So you could, I could ask you a couple different things. So set up part B and see what you get. And then circle the better answer. Is it better to invest for a shorter amount of time at a higher interest rate or a longer amount of time at a lower interest rate? So this one is going to be 1,000, 1.045, and then cubed. Which one was better? A or B? I'm going to get to the end yet. Yeah, I have that A was better. This is what, 1141 and 17 cents. So this one is higher by about what, $18 or so. But you have to have your money tied up for 2 additional years. So maybe you're okay with, I want to pull it out after 3 years and just be done. All right, the Kaufman Fund was the second best fund over 10 years with an average annual return of 26.5%. How much was an investment of $10,000? So if you put $10,000 into the fund in 1988, how much did they have 10 years later in 1998? So they invested $10,000. They got a 26.5% return rate in whatever fund this was, stock or whatever. How much money did they have in the account 10 years later? So see if you can set that one up. It's almost identical to number one. Y equals AB to the X. Or to add to my countdown. 13 days left, right? But who's counting? I am. How many of you wish this could have been snow today? All this rain? If this had been snow, it would have been amazing. Let's see, we want to do 10,000, 1.265. That would be 26.5%, right? Raised to the 10th. Ooh, they did pretty good. $104,000. That's a decent return. $10,000 was a lot of money in 1988. So to invest that much, and you're never sure. So you could take a loss on it, right? Something could fold. They might never turn a profit. So the stock market, there is some risk. It's not a guaranteed return of 26. All right, how much interest will be earned in the first year on $80,000 if you earn 7% compound interest? Careful on this one. I just want to know how much interest. So you can do it the way we've been doing it and then subtract off the $80,000, or you could just do the 7% to see how much actual interest you get. You could just multiply by 0.07, that'll just give you the interest, or you could do 1.07 and then subtract off the $80,000. So there will be one interest problem on your test. Make sure you know how to set those up. I got $5,600 is the interest only. That's pretty good, right? In 1 year, your money makes $5,600 just for sitting there. That's how come people who win big bucks in the lottery can start to live off just the interest alone. Or if you are a college and you have $1 million foundation, is that what it's called? Like they make a nest egg and then they give the scholarship money only off the interest. So they have $1 million in their whatever, such and such scholarship fund. And then the $10,000 of interest, that's where they give their scholarships from, or $100,000 in interest. That way they're never breaking their nest egg. Their nest egg is just making money for them each year. Okay, here's another type of problem that we've seen. Population of two cities, it's thousands. So 63 means 63,000 people, and 51 means 51,000 people. And it says x equals 0 is the year 2015. So that means when you plug in 1, you're in the year 2016, right? 1 year after 2015. So they want you to use these formulas up at the top to tell me what's the population of these towns in 2020, when will Robertsville get to 100,000 or Shawtown 40,000? Will the two populations ever be equal to each other? So I'm going to take a few minutes on your own, use your calculators, see if you can either make a table of values. That's the way my answers. I estimated, so I went in my table, compared Robertsville versus Shawtown. So you can see, like, I went all the way down in the table until I hit number, oops, you can't see this. I hit number 100 in the table, and it represents 100,000 people. That's around year 15 or 16, but I'm starting in 2015. So that would be around 20, either 30 or 2031 for when it hit 100,000 people. And then I went backwards in Shawtown to get to 40,000 people. So if you go backwards and you see when Shawtown was 40,000, the table keeps working as you go backwards. So this is year 2015, 2014, 2013, 2012, 2011. So wait a second, you had said, oh yeah, 2010 is not good enough. By 2011, I should say 2011. By 2011, it hit 40,000. Right, so number 5. So he's starting with 30 pounds of bone weight. And let's see, 10 years has passed, right? He was 30 and now he's 40. And so you lose roughly 2% of your bone mass every year. So if you don't, address it with either calcium or medicine or whatever, it could lead to osteoporosis, weakened bones. We want to set up the equation as he's starting with 30 pounds of bone mass, and if he's losing 2%, he's only getting to keep 98% of his bone mass. So then you can plug in how many years you want to go past. So you use 0.98 instead of 1.02, because you're going down by 2%, not up by 2%. That's a hard one to know the difference between decay and growth. I don't know. Oh, so you went even closer. So you said between your, what did you say? And what did I say? Oh. Oh, okay. So it's between year 10 and year 11, right? And you got between year 10 and year 11. So did you use year 10? Yeah, 2025. Did I say, what did I say? I did? Why did I say year 6? You're right, I misread it. So it should be between year 10 and year 11, right? So it should be between year 10 to 11. So if I take 2015 and add 10 to between year 2025 and 26, is that what other people got for number 4E? Okay, thanks for pointing that out. Right on here. So let's see. We're doing 30 times 0.98 to the, it's been 10 years. So it looks like he would have 24.5 pounds of bone. And then if he's 58, then from 30 to 58 would be 28 years, right? 0.98 to the 28th. 30 times 0.98 raised to the 28th would be 17 pounds. Is that what people got for that one? So then when will his bone weight be less than 20? Well, we know it's before year 28. So you could guess and check, or you could use the table. I'm going to use the table. That way I can just skim down in the table. 30 times 0.98 raised to the x. I know it's less than year 28, so I'll start at like year 20. So by which year does he have less than 20 pounds? I think it's by year 21. So 30 plus 21. Is it by age like 51-ish? Is that what people get? So age 51. And that's if you do nothing. So if you know that, you've got bone loss, that's why, older people drink their, whatever, Ensure and stuff like that to get lots of extra calcium, because your bones do start to